Okay, as usual, this call is going to be recorded for people who want to come and watch it on YouTube asynchronously. Today, we've got quite a few things to talk about. I'm going to start off with a demonstration of some C groups related functionality, and then we'll get on to the general sort of release and development updates and roadmap stuff. We are hoping that soon we'll have a demonstration related to some robotics use of Singularity, which will be interesting. Hopefully we can get that onto the agenda for one of the next few meetings from an external group there. Okay, so we'll kick off then with me just talking a bit about C groups. Now, C groups, which are control groups, are a means on Linux to limit the amount of resource that a process can use, or a group of processes can be used. So in the HPC space, we're kind of familiar with this in terms of schedulers being able to limit the memory or CPUs allocated to a job. But the C groups function in Linux offers this a kind of lower, more specific level. So you can create C groups, assign limits on a C group, and then you can put processes into a C group and they inherit those limits. Now, Singularity has had some functionality to apply resource limits to containers using C groups for quite a while, but it's actually a little bit restrictive how you can do this. So if I scroll down in the documentation, if I ignore the top bit at the moment, we go down to using Singularity to create a C group. We see that Singularity has this flag for the run, shell exec, and so on called apply C groups. And I can give it a path to a TOML file, which is a representation of the resource limits I want to apply to the container. Now, the trouble with this is that because Singularity kind of grew up with a need to support older distributions, which didn't have certain kind of new functionality in the past related to how you can set up these C groups, it required root privilege to use this. Now, that means it's not particularly useful for the majority of users. You can't get sudo, you can't apply the resource limits to your container directly with Singularity. So what people have typically done for resource limits is use a batch scheduler to apply them, or some other means like that. In modern Linux distributions, there's a way to actually run a process inside a C group and apply limits to it as a normal user, as long as the distribution is using a new enough version of systemd and the administrator hasn't blocked this functionality. So this is something that works on the majority of kind of newer distributions post sort of Red Hat Enterprise Linux 6 and so on. So can take a look at this. What we can do with this systemd functionality is call a program called systemd run, tell it we're working as a user, not kind of privileged, and ask it to allocate us a scope. So we'll see what that means in a minute, and set a property, which is a memory limit of 1 GB. And then I can ask systemd run to call Singularity. I'm going to run this memhog.sif container. So if I press enter here, we get a note from systemd that it's running scope as a unit. Okay, so what is this scope? Well, if I cat for my own process here in the container, the C group file, I can see.
sorry to interrupt, but we can't see your terminal. We can just see.
Did it not switch?
No.
Oh, sorry. I don't know. I switched it on Zoom, and I think I'm going to have to leave the call and rejoin. Sorry, I'll be right back.
All right. Cheers. The joys of Zoom.
Hello, can you hear me?
You bet. Yep.
Okay, I'm really sorry about that. I managed to not have my terminal able to be captured by Zoom. So we'll start again. Okay, so what I can do to run a container on one of these modern systems, which uses systemd, is use a command called systemd-run. Ask it for, say I'm a user, ask it to allocate a scope and apply the limits I want. So I'm running this container called memhog.sif, and I get a note that it's running a scope as a unit. Now, if we look for my process in the container, its cgroup file, what we see is this kind of long path here. Now, systemd manages cgroups for system services and for user sessions and all kinds of things quite comprehensively, and it creates a nested structure. So all users sessions sit under a user slice, and then we have one for my account, and then I've got a service portion here, then I've got a slice to hold applications, and then finally this systemd-run actually created all the way down here this scope. And a scope is for a kind of transient C group. So a service is where you have something long running and it has a C group that applies limits to that, and the daemon or the service is managed by systemd itself. A scope is used when we want to just put some process in the C group to apply resource limits and so on. But what's running in there isn't managed by systemd itself. It's not a service or something that's running. Now, what I can try and do here is run a program called memhog. And if I ask it to hog 1 megabyte, everything is good. If I ask it to hog 10 gigabytes of RAM, what we should see is it'll go ahead and fill up all that space. And when it hits the limit that was defined, it's killed. I can exit out of the container. I can look at my message output, and this shows what's going on, right? So because I had a constraint of 1 gigabyte on there, once that was kind of exceeded in this C group that was created, then it killed the memhog process inside the container. So this is great for these kind of newer systems which allow you to do this with systemd-run, and we have it documented how to do this already. However, because it involves quite a long command line and systemd has its own properties for applying things like memory limits, which don't necessarily match up with the names used by C groups under the hood, it can be a little kind of cumbersome to work with that. So what we're working on for 3.10 is to allow Singularity to directly apply C groups limits itself as a normal user runs the container with that same apply C groups method you can use as root. So in this directory, I have a file here called test.toml, and this is just set up to apply the same kind of memory limit. And I can go ahead And in my development version of Singularity, as a normal user now, I can do this. I can run the container. I've got an info line telling me it's setting up a C group in a certain place. And if I look at the proc self C group bit, we now see that we're in this sort of user slice and stuff which belongs to me. But instead of a relatively kind of random name for our scope, we have a nice one. We know it's Singularity with the process ID 6095. So I can kind of manipulate that external from Singularity if I want to go and look at how much RAM is being used or things like that. I've got a nice path I can track down the container to. And we now have in here the same behavior as if we used the systemd run. It's going to consume RAM up to the limit, and then my process is going to get killed like that. So that's really all the demo is. It's not particularly exciting to look at, but what we kind of envisage here is that it'll open up a way for people who want to either manage resource limits of containers easily when they're not using an HPC batch scheduler, so maybe on a large interactive system. Yeah, Dave, you got your hand raised?
I just wanted to, so in the new system that supports the new Singularity that supports V2, is it by default enabled then, or is that something that needs to be configured?
Let me get to that in a second. After we'll talk about why you might want to use it, and then I'll mention what you need in order to use this. Okay, so if you're running on a big node in an interactive session that's shared, something like that. Or if you have a HPC job, and because you are kind of exclusively allocated nodes with maybe 64 cores and 256 gigs of RAM, you tend to run multiple things in a job. You can apply limits on each kind of subpart of your job if it runs in a container. So that's the utility of this. So to touch on what you need here, to do this without privilege in any form, we have to use systemd as the C groups manager. And by default, Singularity is now going to use that from 3.10 onward. Previously, we worked with what was called the C group FS, the file system representation directly, but now we've changed the manager we're using by default, so we go through systemd. The other thing you need for kind of fully unprivileged C groups work is you have to be running on a system which supports C groups v2. So C groups v2 is something that will be on by default if you're running the latest version of Debian, or if you're running the latest Ubuntu's, not the LTS, but the latest ones coming out before 22.4. And if you're running RHEL 8, you can turn it on yourself. It's not on by default. But if you're running sort of RHEL 7, it's not going to be a straightforward option there. Okay, so there's going to be some configuration notes and requirements on this, and we'll get it all written up. But this hopefully allows some use cases to be addressed. And further going forward, what we'll do is not just have this apply C groups, which takes a somewhat cryptic TOML file, but we can also extend the Singularity CLI so that it offers some of the flags that people are familiar with from Docker, where you have -- CPUs, for example, to set the number of CPUs in use. So we can support those types of limits directly through very simple flags, rather than requiring this somewhat cryptic file. Did I answer your question in there, Dave?
Yes, although I also have a related one. Is so if you compiled it on an older machine, would it be able to detect when you run it on a newer operating system? Because I do that. I have a single installation of that I run on multiple operating systems.
Yeah, so if you, unless you're compiling on something very, very old, you're going to be okay. The config file will be set up to use systemd by default. Even if it doesn't support the unprivileged flow in your particular distro, we're still going to default to systemd now for the privileged application of C groups. And then it's just a case of at runtime, whether you've got v2 or v1, whether the unprivileged stuff will work or not. Okay, let's carry on then. What I want to do now is give a little update on kind of development work. We had a 3.9.5 bug fix release as the most recent. Won't dwell on that too much. You can check the changelog for that. It addresses some issues with handling some container startup stuff, which you may or may not hit. We generally, on the development side of things, have been working on the C groups changes, which involved changing out some dependencies which we use for ones which support this interaction with systemd I've talked about, and also looking forward to some of the stuff in our broader roadmap, which we'll get into later, where we are changing the way that Singularity's OCI mode, so Singularity OCI commands work, what they actually use to run OCI containers in the background. So these are relatively kind of big code changes going on at the moment that we will not see the outcome of entirely for a couple of weeks there. Outside of Singularity itself, in the kind of broader ecosystem, there's some work been going on tooling related to remote builds. So I'll invite Mike to talk about that a little bit.
Hey everybody. So what Dave is referring to is a standalone tool called SCSBuild, which will allow you to invoke remote builds from a command line of any compatible system, including Mac OS. We're offering this as a precompiled binary and ultimately a Docker container for anybody that can run Docker to basically launch a remote build. So instead of having to install Singularity on your system, or in the case of like a Mac workstation where you cannot install Singularity, you can still submit remote builds, have them push these CIF files to the cloud library, download them locally, things like that. And this ultimately gives you the ability to integrate into your CI/CD workflow. So you can have automated builds in an environment where you don't need Singularity installed. And we're going to have a blog post probably within the next few days. It's Thursday already, so probably next week, announcing this, giving you a practical example with CI/CD workflows. But in the meantime, because this is released as part of our existing GitHub repository called SCS-build/client, that's SCS-build-client, you can pull this source right now and run it, have a look at it. There are some example CI/CD configurations for GitLab and GitHub Actions there. I perhaps will have a demo of this in a future call, but for now, I just wanted to announce it. It's probably going to be useful to some, and we've identified a lot of users, and a lot of users have asked us about having something like this so they can do precisely that, automating builds. So that's all for now. I'll watch for the blog post probably early next week. Thank you.
We'll make sure the links get posted on the meetings page for this call too, once those are available. Thanks, Mike. So that's it for the moment for the kind of general development talk. We had out very recently an announcement about SingularityCE 4 and beyond roadmap. So this has kind of been quite a kind of dramatic update to the open source roadmap we have, and we talked about the reasons for some of the things that we're proposing in there in this this post that was made. But Adam Hughes is going to chat a little bit about the kind of background and high-level view of that, and I'll be able to join in for answering any questions as well. So Ad, shall I pass over to you?
Yeah, sounds good. Thanks, Dave. Yeah, so I guess, we put out some comms on the roadmap and where that's headed, but I think on this call, I'd love to give some context just around, the reasoning behind it. Sylabs as a company, we support, obviously SingularityCE and open source, and Singularity Pro on the commercial side. I think in both of those environments, we're starting to see a shift that's been happening for a while, but maybe it's becoming more pressing. For me, when we sat down, we boiled down all the feedback that we get from both of those user communities. A couple big things that are happening is a lot of people are using OCI tooling, and often, that's related to kind of the pipelines, kind of this automation of the codes going into containers. Singularity, to take a step back, has always had its own image format. So, in Singularity 3.0, Sylabs developed SIF. This is, really the runtime or the storage format that's really designed for high performance. So I think that's always been a big differentiator between kind of the Singularity ecosystem and the more cloud native ecosystem. But that hasn't stopped people using kind of those cloud native tools and then pulling those workloads into an environment that is running Singularity CE or Singularity Pro. What's interesting about that is, we've never had perfect compatibility. So a common workflow we see is, somebody will pull an existing Docker image or an existing OCI image, pull that into a Singularity environment, and then often it will just kind of work, but sometimes it won't. So, and this really boils down to some, foundational differences in how Singularity works from other cloud native runtimes out there. But what we've heard is, that is what I want. I actually want, the user experience of Singularity. I've got a user base that's familiar with that. I love the performance of the image format, in particular when scaling out to, hundreds or thousands of nodes in a run. But I also want to be able to leverage the best tools coming out of the OCI ecosystem. It's obviously, in a world with Kubernetes, the world's moving very fast in that side of the world, and there's great tools being built there. And to be honest, Singularity's never had a differential story in how you build an image. It's more around how it's packaged when you run it. So I think what you'll see in the roadmap, it's Dave Trudgeon that's driving this forward on the Singularity side. So I want to give credit there. But really, this roadmap's all about how do you take kind of those, those workflow advantages of Singularity and the great performance we have in that image format, and make it, as compatible with OCI. And really, the vision here is perfect compatibility with OCI. So I think, that's what we started out with as a design goal. And then around the margins, what you'll see is really people are starting to build SIF images in automated ways. So these are kind of going from, I bang stuff together on my workstation, then I chuck it to a scheduler manually, to some of these workflows now are, full-blown CI/CD pipelines with SIF images coming out of them, but also OCI, tooling being used in there. So I think, when we look at the roadmap for Singularity and even, the remote build stuff that Mike's putting out shortly here, really it's to support these kind of new workflows we see emerging in HPC. And really, the vision is, kind of keep your workflows as they are, but be able to leverage OCI based images, perfect. And, further down the line, as we look towards Singularity 4.0, that's really a theme. Interesting to note, so we're sort of sitting on the performance computing side, performance intensive computing side, and being pulled in this direction of kind of cloud native and OCI. there's another shift happening too on the other side, where we're actually starting to see, runtimes like Podman actually start to leverage the Sylabs implementation of SIF. And I think there's a realization there that, there is value to that format from a performance characteristic point of view. I think it's natural to ask the question then, what does Singularity Build bring to the table if you've got, OCI tools like Podman starting to adopt this sort of runtime format? What's the advantage? What's the long-term plan for Singularity? I think that the main advantage as we look at it from the development community is, this is a runtime that's built for performance intensive compute and batch compute. And the way that people work in these environments really, that's always been our basis. So, having a really great performance is kind of built into the DNA of Singularity, but also just having the simplicity and ease of use in the workflows, I think, it is a big benefit when we talk to people about, their plans for a year or 2 or 3 out. They love the simplicity of Singularity and even some of the cloud functionality around it. So lots of words there, but I guess if there's one takeaway message, really, it's that I think you're going to see a lot of change under the hood in Singularity. We're going to be moving towards having great OCI compatibility, and for those out there, that might be kind of a scary message to hear. There's a lot of change going under the hood. I'll just add one final thing that we've always had as a community in Singularity and as a company in Sylabs, kind of we respect that these environments need to have stability. They need to have predictability in running workloads. So hearing about changes under the hood can be very difficult to plan for. We do have a strong story there for compatibility and our plan going forward. And the post that Dave mentioned, Singularity 4.0 and beyond, really worth taking a look at for that, how that's going to unfold under the hood. So yeah, I think that's about it. I'll pause there. If there's any questions, happy to take them. And otherwise, I'll pass it back to you, Dave.
Are you planning on having a separate development branch for this? Separate from master?
No. So the intention is to kind of tackle this in an iterative approach over the course of several releases of Singularity, always maintaining compatibility and stability as a goal. So I can kind of talk a little bit about what we've got on the roadmap now, and hopefully that'll show some of this. What I'm sharing now, what you can see here, this is the message that Adam mentioned that we kind of put out, talking about the general approach that we're going to take. And we've got further down responses to a lot of the questions we kind of anticipate people might have about this work. Why do we actually need to do it? Why would you stick with Singularity if we're going to change? Why we're really focused on being stable and avoiding risk and so on. But really, what we can look at here are these 3 points, right? So in Singularity 3.10, we start off with changes which are quite kind of hidden from most users, because what we're going to do, and we're in the process of doing right now, is stopping our use of Singularity's own runtime with the Singularity OCI commands and replacing it with calling out to an established open source OCI runtime. So run C is what we're using here. So for those who aren't aware, Singularity OCI commands are there to try and provide a mode of operation for Singularity which is compliant with the OCI runtime specification, which says that containers have to go through a certain cycle, a life cycle with different states. The disk layout of the container has to be a certain way according to an image spec. and the configuration is controlled by a particular config.json file, which has a certain format and content. So the Singularity OCI commands are one where you can take a CIF file and you can mount it into an OCI bundle, and then you can start or run that resultant container in a way that exactly conforms with the OCI runtime specification. So this mode of operation has only been usable as root at present, and it's honestly not terribly well known. It was previously used in some integrations, which have kind of ceased development, but we're using it as the entry point to bring in the better OCI support without affecting the kind of main workflows with Singularity that people think of, the run shell and so on of our CIF files. So we start off there, and then in 3.11 the intention is to move on so that we basically expose the ability to run native OCI container image, not a Singularity container, but something directly pulled from like Docker Hub and not translated into Singularity format via our existing CLI that people are familiar with. So the shell exec run, okay? Again, this doesn't have any impact on running or building your Singularity containers. This is additional functionality, so you can run native OCI images without translation in an OCI compatible manner. We want to start that process in 3.11 to support much of the kind of functionality Singularity offers in its CLI when you run those images. And then in 4.0, the intention is to move on from there and provide a means to encapsulate OCI images in CIF. So instead of having images as layers, which are splat out on disk and have to be managed with an accumulation of overlays of directories on disk, this is about bringing the OCI image without translation, just encapsulating it in a CIF file. So it's easy to move around on an HPC system. You have the performance benefits of that single file access, but it's not a translation. So you're not losing fidelity in the way that Singularity currently does by having to extract the layers and kind of convert it to its own format. So all of these are kind of, well, the 3.10 is a change to our OCI engine, but the other points are additions, right? These are new ways of running OCI images truly compatibly. And by compatible there, I mean, not just in accordance with specific parts of the OCI specifications, but more holistically, thinking about what a user sees as OCI compatible, which is really that when I run a container of Docker Hub with Singularity, I want it to act exactly like it does with Docker, that kind of thing.
So in particular, one of the hardest parts about that is the support. You start up when you run a Docker image, it brings you with the root prompt, right? And you can switch to other users. So how would you intend to do that in Singularity 3.11?
I mean, we, like I said, in 3.10, what we're looking at is we're replacing our own OCI engine by integrating an existing OCI engine. And what we're going to do is leverage all the work that's gone on in those to kind of permit this type of stuff. Now, there are some caveats, right? Which are that, like, if you're doing things rootless, you need certain support from your operating system and your Linux kernel to accomplish these things. But what we're trying to do is expose this functionality so that as people kind of move up from Red Hat 7 into newer distros and things, this compatibility is there, but we're not going to break our kind of native Singularity containers, our native runtime, which people are dependent.
So I guess it will be dependent if it detects that it's an OCI container, then it's going to behave with that needing the new UID map or a set UID route, right? But if it's not an OCI container, then it'll have its old behavior.
Yeah, I mean, there are different things we have to consider, right? So you have various things. The obvious one is to support the highest level of fidelity that's possible on the system automatically. But equally, people might want to stick with the old way of doing things with translation until they're able to switch wholesale to a new way of doing things. These are areas that we're definitely considering and exploring. So the reasoning for putting out this announcement, talking about it, having a roadmap now, which is going out through 3 releases, which is kind of over 18 months into the future, is so that we can explore these and really talk to people and see how they would like to interact with this functionality. Okay, so as we pointed out, we've got this announcement with the kind of Q&A below. If you're interested in some more details about specific points on the roadmap, the SingularityCE community repository is, as always, open, and we publish things we have for the roadmap here, and we encourage people to get involved and comment and add things that they need here too. We've gone through and updated this, and if you go through, you'll see for 3.10, for 3.11, and for 4.0, we now have the bulk kind of points for this roadmap on there. And these are being fleshed out onto GitHub issues as well. So please take a look at the roadmap. If you have any questions, you can reach out to us in any of the places, this call, the Slack channel, the Google group, and so on. And I'll also note that this is, if you're interested in kind of contributing to Singularity, potentially an interesting time to get involved, because we're going to be making some quite significant changes to the code base in some of the kind of important areas which control really what's going on under the hood in Singularity. But there's also going to be a bunch of upper level work on like the CLI with relatively simple logic changes or flags or things like that. So there's going to be a wide range of tasks at different levels, which offers the opportunity to kind of learn quite a bit about the code if you've ever wanted to dive into it. We're extremely keen to have anyone who's interested get involved in development work. So if that applies to you, please reach out. And this is not only for these kind of main roadmap aims we talked about with regard to OCI, but also other things. If there are specific changes which would bring significant value to your organization, yourself, how you use it, and you would like to kind of pursue them, come and chat, and we can help you kind of understand where to start looking in the code and work up towards submitting contributions to the project.
Hey, DT, for somebody who wants to get involved at the developer level, what's the best place to reach out to start that process? Is it Slack? Yeah,
I would say that generally, if you've got a very good idea of what you want to do, a great thing to do is in a GitHub issue, explain the problem and kind of propose what you're going to do, and you'll get kind of technical feedback there quite specifically. If you need some more general information about how to get involved, then Slack is probably the best place to join. Singularity does have some difficulty involved with setting up an environment where you can test things effectively and so on in some cases. So if you are interested, we can certainly help you out with those things. And equally, we want to make it easier for people to jump in and get involved. So we're keen to tackle the points of friction that people hit as they work on the code. Okay, any kind of general questions on the roadmap stuff? If not, let's open it up to anything at all. Is there any Singularity related topic that you want to bring up, or you have any questions? Anything at all? The floor is open.
Sounds like
Okay, well,
a bit of a job of explaining things.
yeah, sorry if we've been talking a little bit too much and made you nod off, but hopefully we've given a decent overview of this roadmap update and what it's about. Like I said, reach out if you have any questions and so on. Slack or the Google group, or you can bring them to this call next time. So every first Thursday in each month, we do it at the same time on Zoom. And like I said, we're currently trying to arrange some additional demos. You'll see in upcoming sessions the build stuff that Mike was talking about. We'll get that on the agenda. And fingers crossed, a demo of some exciting use of Singularity in the area of robotics. So that's something to look forward to. Otherwise, we'll call it for now, and we'll finish 15 minutes early in the slot. Thanks for joining us.
Thanks. Take care.